Welcome to the data science track. I want to start off with a little vote. So if you guys can get out your phones and vote on whether you think that this sentence is a positive, a neutral, or a negative statement. I'm getting a little feedback. Meanwhile, I'm going to continue. The slide's going to come back if you want to see the code. But today, we're going to talk about BERT for sentiment analysis. And not just normal sentiment analysis. No, we're going to look at sustainability reports. But what exactly is a sustainability report? Well, a sustainability report is basically a report that's in addition to the annual report, where companies publish about their economic, environmental, and social impacts due to their everyday activities, and also about their vision and strategies surrounding these topics. We have a department within KPMG that is the sustainability department, and their job, or one of the things that they do, is they read these reports and they have basically an opinion about how good it is. They have to give a stamp of approval. The way that they do this is by a set of standards provided by the Global Reporting Initiative. I bet you didn't think that was a thing, but it is. And they give these 6 metrics by which they judge whether or not a report is good enough, and one of them is balance. Balance they define as, or a well-balanced report, is when it reflects both the positive and the negative aspects of a company's performance, so that you can give a balanced overview to the stakeholders. Now, it might not be in the company's best interest to talk about the negative aspects of their company, so what tends to happen is that this balance is a little bit skewed towards the positive. Because what you often see is that statements, they like to pump up their positivity. So you get statements like, we create huge value for society, or our technological breakthrough will support the global battle against climate change. Now, these are pretty strong statements, and again, the job of my colleagues is to take these statements, go back to the colleague, and be like, hey, maybe you should adjust these a little bit, make them reflect reality a little bit more. But this is a tough thing. And what they discovered is that they had some issues that they encountered while doing their regular job. One of them is that, like I said, different people have different opinions when it comes to sentiment analysis. So, for example, this might occur on a personal level. If you're in a bad mood, you might judge them more harshly than if you're in a better mood or your workload is lower. The same thing happens with colleagues. Colleagues amongst each other might have different opinions. And of course, it also happens when you go into discussions with the client. They often will defend themselves, and you have to tell them why you think they need to change. So this is one of their problems. The second one, that this takes up a lot of time. They have to read the report not once, but usually multiple times, and these reports can be hundreds of pages. So finding these examples where they want to start a discussion takes a lot of time. The last thing, because of these 2 first issues, basically it's very hard for them to do a comparison between different reports. So to say that one report is well balanced, but the next one isn't, is like a really hard discussion. Also, they can't really compare to the same company's previous reports or the year before that to indicate changes or trends. This is stuff that we really want to do, but it's very hard to do at this moment. So basically, they asked us, can we quantify balance? Now, the first thing, obviously, that they thought about was sentiment analysis. So they asked us, can you do sentiment analysis? We were like, yeah, of course we can. And we did. Actually, we tried a lot. We found a whole array of different sentiment analysis models that are already out there, which are pre-trained. Some are commercial, like Heaven on Demand. Some are open source, like the Stanford Sentiment Tree Bank. And we basically tried all of them. What you can see here is where I show the same report, analyzed by all of these different models, with the sentiment aggregated per page throughout the entire document. So this document has almost 60 pages. Now, we saw cases where the model decided that the whole report was negative. We saw cases where they decided the whole report was positive. We saw a continuous scale. We saw a binary scale. But what stood out the most is that we couldn't find any sort of agreement within these documents or these models, that it didn't seem to indicate like a general sort of pattern of positivity or negativity anywhere within the document, which is what we would expect if these models, well, worked on our kind of data. So what was the problem? Well, the problem is that most of these models are trained on different kind of data that we were looking at. A very obvious sort of data set when you look into sentiment analysis is reviews. They're usually nicely written with like strong voiced opinions. People either love a product or they hate it. That's when you tend to write a review. And you automatically have your labels because they often come with a rating or like a star or a score. So these are typically the kinds of data that the model is trained on. But this is not the data that we were looking at. We were looking at reports written by companies, which were closely related to annual reports. So it's a very different kind of language. Now, I showed this slide at the beginning where I asked you guys if you wanted to score one of these things. So I really like this result because, as you can see here, a lot of people voted positive. If you guys want to vote still, you can now. But we can see there's already some disagreement. There's a few that are saying negative or neutral, but most actually are saying that this is a positive statement. Now, we went to our sustainability colleagues and we asked them, what do you define as a negative, neutral, or positive sentiment that you want us to find? So what they said, the positive is pretty obvious. Positive is bold statements, anything that's overly positive, where they talk about their achievements or some great value that they add to society. Neutral is factual information, anything that contains both positive or negative sentiment, like the stuff in between. But the negative one was going to be the hardest to find because companies don't say our product is bad or our service sucks. They say we see a risk or we see a challenge. We see opportunities for improvement. Now, the words used in these kinds of sentences could be viewed as positive. Most of you actually said that the previous sentence was positive, but by these definitions, this sentence is negative because they're talking about a risk that they've identified and they want to improve in the future. So we needed a model that could handle these kind of, well, let's say complex natural language understandings. So we needed something a little bit more sophisticated. So we got BERT. So what is BERT? BERT is a model which was trained and published by Google. It stands for Bidirectional Encoder Representation from Transformers. Of course, this is probably a backronym, but that doesn't matter. What you can view BERT as is like a general language understanding model. You can use this model to do various NLP tasks. To kind of understand how BERT works, I'm going to take a few steps back and talk about vector representations. The way that you want to train a model is, as we saw in the previous talk by Jay, is you do calculations. Now, to do calculations, you don't need words, you need numbers. So you need a way to represent those words into numbers. The very basic way of doing this is to create what's called a one-hot encoding. You basically take a very long list of all of the words that appear in your text at least once, you give each word an index, and then you give each word a vector where you only put a 1 in the place of its index. So Rome, in this example, only has a 1 in the first index, and Paris only has a 1 in the second index, etc. Okay, great. So now we have a vector representation. But of course, these vectors don't contain any sort of meaning the way that we would understand the relationship between words. Like, sure, like in this example, Rome and Paris are both cities, but it's just coincidence. If I change the order of my list, I get different vectors. So how do you solve this? One of the first things that was done to build like good vector representations for words was what's called a word-to-vec model. The way that a word-to-vec model works, it's basically a variation of an autoencoder. And an autoencoder has a neural network which has the structure of kind of an hourglass. So you have a large input, a small stuff in the middle, and a large output. And you try to predict the input itself. So what happens as you get better and better is that this smaller stuff in the middle will create a smaller vector that can be used as a representation of whatever you're trying to predict, in this case, words. So what a word-to-vec model does is it loops over all of your text like a sliding window. It tries to predict the word that is in the middle using the words that are around it. So intuitively, you can see that this will create vectors that represent the words by their context. Words that are similar, like king and queen, will be close together in this what we call the vector space or the latent space. The same way we can see the relationship between king and queen, we can also see this relationship between man and woman. The same goes for verbs, so walking and walked will be close together. So great, we now have representations for our words, but there's one more problem. We have words which have different meanings, but are the same word. So let's take the word bank. If I say I walk down to the riverbank, I'm talking about a location, a geological location. But when I say I walk down to the bank to make a deposit, I'm talking about a financial institution. The problem is that with this method, the vector representation of the word bank will not appear either with the geological locations or either with the financial institutions. It will appear somewhere in the middle. So you lose kind of some of the specific context that you're looking for. So one of the ways that this was solved is by way of a sequence model. What this tries to do is, well, given a sentence, you predict the next word. So the word will now have a vector representation that is actually dependent on the words that came before it. So now we have a good representation for the word bank if I'm looking at the sentence, I walk down to the riverbank. However, if I look at the example, I walked out to the bank to make a deposit, the information containing that this is about a financial institution is now behind the word. So we're only halfway there. But we can simply solve this by also doing the same thing but backwards. So we try to predict the word that came before it and concatenate the results. So this is good. This worked really well for a while. But then came BERT. So what actually is BERT doing that's a little bit different than this? Right. So what we now have is what's called a contextualized word embedding. And BERT tries to create the same thing, but in a little bit of a different way. I'm not going to go into the whole thing about what kind of architecture is behind this, but if you want to read up on it, there's an excellent blog post, actually by Jay, which goes into the details of what a transformer is and also about how BERT works. But what I want you to take away from this is that BERT tries to predict words in the middle of a sentence by simply masking them. So that way you get the entire context of the sentence when trying to predict the word, which will then have a better, as we've seen, representation using the entire context and not just going back and forth, but the whole thing. But not only that, BERT does a little bit more. It also is trained on what's called a next sentence prediction. So what we see here is that we have two sentences, and they are also surrounded by two specialized, well, what we call tokens. So the first thing, the CLS token, and the second one, the SEP token, indicate different things within this model. So the SEP token is just to separate the first sentence from the next, so the model knows where the next sentence begins. And the first one, the CLS token, is going to be very important because it's the classifier token. So in the architecture of this model, the CLS token has as output its own vector, which is used as input to predict whether or not this next sentence follows the first. Now they do this obviously on a whole bunch of different texts. So eventually, when you do this enough times, this CLS token will not just be a random representation, it will actually start to represent the entire first sentence. And that's where we can use it to do classification. So the BERT model can be used for different things. You can do something that's called named entity recognition or Potter speech tagging, where you want to recognize what kind of words they are. You would do this on the output of the different tokens related to those words. But what we're looking at is classification. And for classification, we want to have the representation of the entire sentence. So we look at the output of the CLS token. What this would look like in training is we have an input sentence. This is then tokenized, which you can see in the second one. We add the CLS token and the SEP token. The second sentence, in this case, for us doesn't exist. We don't need it, so it's just left empty. We run the whole thing through the BERT model, which is pre-trained, has all of these embeddings, and we use the output from that model into our classifying layer. And this is then what we actually train our own models, or labels, and in this case, a positive one. Now, when BERT was first released, there were two basic models for English that they made. One is BERT base. It's a smaller model. It has 12 layers. And then the BERT large model, which has more layers. Now, I have some beef with Google because I don't like the name BERT base, or BERT large rather, because I think it should have been called Big BERT, because it's Big BERT. But I shouldn't complain too much, because over the past year or so, there's been a lot of new development on this topic, and a lot of new models have come out, which use the BERT architecture, but are trained on different languages, or they're optimized. So for example, for French, we now have Camembert. There is also one for Dutch, which is called Robert. There's a light version of BERT called Albert, a light BERT. And we also have another optimized version, Tiny BERT, and there's like a whole bunch of other variations. So there's so much progress still going on. Also, there have been plenty of implementations now into different kind of libraries. There's an implementation in PyTorch and Keras, and Hugging Face is a really good place to find all of these embeddings ready for you. So if you want to start out with using BERT, I would highly recommend checking out the Hugging Face repository. So now back to our use case. We're going to fine-tune BERT to our specific data. What is the data? Well, the data that we had was almost 800 sustainability and integrated reports. Integrated reports just being an annual report where the first half is about the sustainability topics. Most of them had around 90 pages. And we extracted all the data. And the only sort of pre-processing you have to do for BERT, which is quite nice, is split it up in sentences. There's a lot of NLP sort of pre-processing tasks that you could do, like stemming or lemmatization, if you've heard of those terms. But it's all not necessary for BERT. You can just put in the entire sentence, and there's a specialized tokenizer that will make sure that the model is able to handle whatever you give it. The original model by Google doesn't only come with the architecture and the weights of the model. It also comes with some scripts for you to run for a classifier or any other task that you want to do, except that the whole thing is written in TensorFlow. Personally, I don't really like TensorFlow. I don't know if that's like a controversial opinion, but it can be very dense, and especially this script that they've provided was a little bit hard to use for the simple use case that we had. So the first step that we did, which is now already done for you, so you don't have to do it again, is we implemented this thing in Keras. And Keras has a much nicer interface for you, where you can build up your model, you can do predict, you can do train, etc. And it's just a little bit more intuitive. Also, this was before TensorFlow 2.0, which now already has this layer of Keras in front of it. But one of the nice things about Keras when you've built your model is that you can do this nice summary. You can actually see what the model looks like. This is a snippet of it. And we can see the actual input and the output of our model. So the input in this case is 50 by 768, where the 50 is referring to the number of tokens that we're putting into the model, so basically the number of words. And then the 768 is the length of each of the vectors. So it's quite a large vector space that's being created by the BERT model. Our output is only 3, because we're only interested in 3 labels, and it will be just the probabilities of the sentences belonging to each of those labels. So then we needed data, obviously. So again, we went back to our sustainability colleagues, and we're like, hey, you want to create some labels for us? So they spent 2 days going through a whole bunch of random sentences and gave them the labels that they wanted. We ended up with 8,000 labels. And as you can see, the negative sentiment was quite underrepresented in the data set. So we were a little bit worried whether or not this was going to work. But we crossed our fingers, threw the data into the model, and asked ourselves, is this going to work? Yes, otherwise I wouldn't be here. So yes, it worked. But what were our actual results? So we ended up with an accuracy of 82%, which was decent. And when we looked into the results for each of the labels, we saw that for negative we were doing 71%, positive 80%, and neutral, obviously being there the most, was the highest. But what we were actually the most happy about is that the model seemed to be, well, it didn't make any confusions between positive and negative. So all of the 18% that it got wrong was always between a negative and a neutral statement or a neutral and a positive statement. And since we already discussed that labeling these sentences is quite hard and there's a lot of like gray areas, we were quite happy with the fact that the model was able to separate them at least in those two directions. And also when we dug a little bit further into what it was actually like getting confused about, we could see these two examples. So the first one is something that BERT labeled as neutral but was, or predicted as neutral I should say, and was originally labeled as negative. But when we showed this to our colleagues as well, they were like, yeah, you know, it's fine. I'm not really mad about this one. And the same was for the other one. So they actually said it was a neutral statement, but BERT said it was a positive one, since they're talking about an achievement, we can assume. But what we were most interested in is, was it able to detect these hidden negative sentiments? And it was. So unlike you guys, it was actually able to predict correctly that this sentence was a negative statement. Yay. All right, so back to their problems. We created this model for them, and basically we fixed the second one. So we were now able to quickly go through all of these documents and have them presented for them, give them some examples of problems or sentences they should pay attention to. But what we didn't exactly solve is that different people have different opinions. We worked closely together with only 2 people from the sustainability department, so basically it was their input that was put into the model. So we needed to make sure that the model was generalized enough and wasn't just copying these 2 people. So what did we do? Well, we asked other colleagues from their sustainability department to also label a bunch of sentences. We all gave them the same set. And then we checked how often they agreed. Well, it was only 73% of the time that they actually agreed. And most interestingly, they even had cases where they didn't agree about the negative and the positive statements. So they were reversing things. So the next step obviously is checking like how well is BERT holding up to this, what it was actually doing better. So we got 81% agreement with BERT and all of the people. So what did this provide for them? It didn't sort of solve their problem of different people having different opinions, but what it did give them is a stable way of now analyzing all of these reports, because BERT at least is going to agree with itself. And you could do like a bulk analysis of all of these things, so you have something to compare to, which was very important for them. So obviously now that you can analyze one report, you can analyze a whole bunch of reports, you can analyze reports from the past and reports that are coming in. So we can make comparison with peers, competitors, or analyze trends. So great. Now I think I'm pretty good on time. Not really sure how long I've been going. But I kind of want to show you a little demo of what it looks like for them. Oh wow, it is even more for positive. So this is just a demo. This is not what the actual interface for them looks like, but it's just to give you an idea. Oh yeah, I should also tell you that we've named our thing the Subject Extraction and Sentiment Analysis module, which is why it's called Sesame. But what we can do is just upload a report. So, of course, I'm suddenly at slides, which is not what I want. Oh dear. Where did I put it? Okay, so does anybody know any good jokes?
What do you call it when someone believes in deep learning and it works forever?
Where the fuck is my stuff? I don't know, Vincent, tell us.
Naive bias.
Tough God, tough God. There we go, okay, I found it. So, our report. The first thing this does is just give them a little preview of what the actual PDF looks like. And then the first step that we do, obviously, is extracting the raw text. This is just also to give them an overview of if everything is going right. You have actually, so we're usually analyzing reports that are made in PDF, so they're actually extractable. Well, what sometimes happens is that these things are scanned, and then PDF Creator already OCRs this data, so then it's a little bit iffy. So it's just for them like a visual check to make sure that everything's going correctly. Like you can see, like this is supposed to be difference, but there's a little question mark there. So this might pop up later. So it's also to give them a visual. We've also added some other nice features, which is what I talked about before, part of speech tagging, where you can actually see if something is a noun or a verb. The same thing with named entities. Now the named entities one is working okay, but it appears not to really like Dutch names that much. So I would think Jan Homme is part institution and part person. It's just a person. But most importantly, we now have the sentiment as well. So we can show them what are the negative and the positive sentences that are labeled in this particular report, and they can check it, see if they agree, if there's something that's weird about it. And also, again, it gives them these examples that they want to discuss with the client. Furthermore, which is what they probably use the most, is that it gives them a nice overview. So this is again what we saw in the beginning, is as an aggregated view per page of the sentiment throughout the document. And on top of that, we also have the topics here, which we've created with an unsupervised way of finding topics and documents. Additionally, if they do want to check here, like, oh, this is a weird spike, I want to know what happens here. So let's go to page 107. And then below it, we can see all of the sentences, and they can see which ones are labeled negative, and gives them an indication why and what it is about. So, yeah, topic modeling. This is what it looks like for them. They like to work in Tableau, so they've made their own dashboard with their own colors. And most importantly, they also are attached to the actual database, so they can make these comparisons between peers, competitors. Here you see comparison between us, EY, Deloitte, and PwC. Apparently, we're a little bit more positive. Don't know what that tells you, but we are. Then we can also see that the sustainability reports tend to be a little bit more positive overall than the annual reports, which actually makes sense because we see a lot of the times that if we have an integrated report, that the financial part of the report usually does contain some negative sentiment, but not a lot of positive sentiment. Probably because they're reporting on like incidences and all that sort of stuff, which is already flagged as negative. So that's why the annual reports tend to score a little bit lower. Now, as a closer, I saw that the QCon website promoted our social media. I don't actually use my Twitter, but what I did make was a Twitter bot, which is trained on our shower thoughts, if you're familiar with that. It doesn't actually have any followers except me. So if you guys want to follow for quality content like this, feel free to. And otherwise, you can just contact me, obviously, via email or LinkedIn. Thank you very much. Do we have time for questions? Are there any questions? I see one here. It's so bright. Yeah, he has a, right? Yeah.
Thanks a lot for thanks a lot for the great talk. But I'm trying to understand what is the aha moment here, right? Because BERT for sentiment analysis is quite commonplace, at least from what I understand. And I think the big turning point was when you used the team actually to do the labeling for you, right?
Yeah.
Is there anything else that I'm missing in terms of what makes this a hard problem to solve? Because we have done something similar for, let's say, contract analysis, research reports, analysis on different companies. So I'm trying to see what is the thing that you did differently.
Well, we didn't do anything differently per se. It was just that we found that the models we were using at the time weren't able to especially detect this, let's say, hidden negative sentiment that they were interested in, because we needed just something that was a little bit more, better able to build these representations that actually made sense in that context. And BERT was one of the first models that came along that we were like, hey, this can actually work. Now, obviously, this was created over a year ago, and since then, there's been an explosion in these kinds of analyses. So yes, you're right, this is now very commonplace. But usually, those kind of analyses are, again, done on reviews or Twitter data. It's a different kind of language.
Questions? There's one in the back, and then coming here to the front.
Thank you for the interesting talk. I have a question in terms of your evaluation metric. You're looking at accuracy, but since you're doing classification, I wonder if that is a good metric to look at. Are you also looking at the precision, the recall, F1, other evaluation criteria?
I mean, we could. The reason that we were looking at accuracy mostly in the first place is just, one, it was the easiest, but we already knew that this was not going to be perfect, and no kind of metric that we were going to choose was going to be, like, we weren't going to be able to optimize for any of those metrics, because there was always going to be this gray area that we're going to have to cover. So we were actually more interested in being on this like vertical line of these confusion matrices. So that's what we mostly were looking at. And then spot checking, what was it doing and why was it doing it. So, yeah.
Thanks for sharing, that's really good. I'm looking at a problem at the moment where I'm doing real-time classification of speech to try and say somebody on the phone, and we can say that sounds like a personal injury claim, in which case we'll start to ask certain questions. And my assumption was I would go down a very similar route of we already have the text classified as the sentences are the words that come for a personal injury claim, so I have the data to train. Does this feel like it's still state of the art in terms of solving these sorts of problems, or should I be looking at other approaches?
I mean, definitely, as far as this model goes, it's still, I mean, I can't say it's unparalleled because there's this new model that came out, I think, a few weeks ago by Microsoft, but it has obviously 17 billion parameters, and there's no way you can run that on a, like, fast on a small instance. So yeah, I think it's definitely still worth to check this out. Also, definitely check out the optimization versions of BERT, so TinyBERT or Albert. I think that might be a very good place to start. Yeah. Any other questions?
One.
Oh.
So BERT is still, let's call it a relatively maybe complex or like advanced model, so to say. There's also more simpler models. What I was wondering, did you also benchmark it against the simpler things, or did you start with BERT immediately?
I mean, were you here for the beginning of the talk? We started out doing a whole bunch of analyses, which were these, so I went too far.
In that case, what was the uplift?
Sorry?
What was the uplift of using BERT then? Because I don't recall, like, what's the benefit of using BERT compared to the other ones?
Well, the benefit was that these didn't work.
Oh, right, so okay. I didn't hear an accuracy number, that was what I was wondering about.
No, yeah, I have those metrics somewhere, but I didn't think it was that relevant for this presentation.
Low that
yeah, so mostly, especially the negative ones, it just wasn't, like, most of these times it was either, like, these things just all negative or all positive, or it was just saying everything was neutral, which is obvious since it's the biggest class. So it wasn't really able to pick up, like, sometimes you would get good results on the positive sentiments, because those are, like, very obvious big statements, but it was especially the negative ones that were hidden as, like, positively framed that were very difficult to catch, and we only had good results when we used the BERT model.
Cool.
Questions? Going once, going twice.
All right.
All right. Thank you very much, Susanne.
Thank you.
Appreciate it.